Konnichiwa, hajime maste. Watashi wa Mustahoshin Hussein Ahmed Afif des. SystemSage Solutions, the lead engineer Toshite Hataraitemasu. Today, I will present our smart agriculture and aquaculture monitoring system, an end-to-end IoT solution that revolutionizing remote farming operations through sustainable solar power technology. We have engineered a comprehensive solution that provides real-time monitoring, automation, and control using cellular networks. The system delivers advanced analytics for data-driven decisions while maximizing efficiency, ensuring reliability, and significantly reducing operational costs through green technology. Our versatile platform serves four key sectors. Remote farms benefit from automated crop management, ensuring optimal growth conditions. Aquaculture operations maintain critical water quality and feeding schedules. Greenhouse achieve precision climate control for year-round cultivation, and industrial sites gain remote monitoring and control capabilities. The system provides automated irrigation, continuous water quality monitoring, comprehensive data logging, and instant alerts, dramatically reducing manual labor while enhancing operational efficiency and accuracy. Our robust technological foundation spans six core areas. Software and application development creates intuitive dashboards and control panels. Our cloud and backend systems ensure secure data pipelines and real time synchronization. We integrate AI and data intelligence for anomaly detection and smart automation, networking and connectivity leverage, cellular integration for reliable remote operations. This comprehensive approach ensures reliable, secure operation from edge to cloud. The diagram illustrates our unified architecture from sensors collecting environmental data through our edge nodes with cellular LoRa connectivity to cloud servers hosting our APIs and databases, finally reaching our user-friendly monitoring dashboards. Every component works seamlessly together, powered by sustainable solar energy. Our software showcases speak for themselves. These are actual screenshots from our deployed systems. We have created intuitive interfaces that provide real-time data visualization, comprehensive monitoring dashboards, and automated control systems that operators can easily manage from anywhere. Here you can see our actual hardware deployments in the field. Our solar-powered monitoring stations operate reliably in challenging environments, from water monitoring systems to complete agricultural IoT installations. Every component has undergone rigorous testing and field validation. As the lead engineer and project manager, I spearheaded every aspect of this system's lifecycle, from designing the comprehensive architecture, coding and overseeing full stack development, to managing hardware integration, writing the firmware for the network connectivity, and leading an 8-member cross-functional team. I handled project planning, documentation, coding, deployment, and maintained effective communication with international clients and stakeholders. These photos represent real achievements, from presenting at international conferences to successfully system handovers with clients, university collaborations, and winning competitions. We have successfully deployed operational systems in live farm environments, achieved robust security integration, implemented automated automation that significantly reduces manual site visits, and earned recognition for our innovative contributions to smart agriculture technology. For Japanese companies, I bring proven experience in secure IoT communication solutions, reliable real-time control systems, and comprehensive expertise spanning software development, hardware development, and system integration. My approach embodies discipline, precision, and commitment to reliability, values that align perfectly with Japanese engineering principles. I'm ready to contribute to your organization's success through end-to-end system ownership and continuous improvement focus. Thank you. Now I will showcase our software and hardware components. Hello everyone. This is our application which you can access from here, app.systemsage.tech, and this is our website, systemsage.tech. Um, you can even install the software. Let me just log in first. Okay. There's a separate admin panel for this application, which I will show later in the video. We can also install it as a desktop application. So let's just do it. Okay. So yeah, so our main focus was to build a complete system for monitoring and control for various industries. It can be agriculture, it can be aquaculture. So based on that idea, SystemSage, we created this software. On the very first view, you can see the environmental monitoring system. The data we are collecting from the ground, you can see here, it will update automatically every after 2 minutes. You can see the trend here, you can see the air quality, you can see the temperature, humidity, pressure. You can also see when it was last updated. You can also refresh it directly from here. So there is dashboard as well. So for this dashboard, I'm focusing on agriculture part, but we have another dashboard. So the dashboard is same for all types of sensors. We just change the values or the parameters for different sensors. So you can see plot one, plot two, plot three. So we divided a huge land into separate small plots so that you can easily monitor what's happening in each plot. So if I go to plot one, you can see what's the soil condition in that area. Okay. How's the nitrogen, phosphorus, potassium, soil pH, soil moisture, soil temperature. It not only shows you the data, it also tells you what's the condition. Okay. So you may see lots of softwares which are only focusing on delivering the data, showing the user data, but the user doesn't know that what's the data means. So we are also showing the data and what's the condition. You can see directly from here based on the data. You can also see the things, the soil nutrients directly from here, and the trends, what's happening in a certain period. You can see here. It's same for plot 2 as well. See? So there will be separate sensor plots for um, each plot. You can also check certain values, let's say ENV data for last 5 days. So you can see the highest values, the average values, the lowest values. Okay, and you can see this data as well. And if I go to plot one, let's choose maybe 6. No data on that day. 15th. Yeah, you can see the highest values, the average values, the lowest values, and it will help you to understand what's happening around a certain period of time. So you can see directly here from here. We not only show the data, we also show the status of that field. We also tell them what needs to be done. So the farmer directly knows that how much fertilizer needs to be applied in the soil. So he or she can directly see that it's written in Bangla, what needs to be done in the field, how much fertilizer he needs to apply, how much water it needs, what's the minimum temperature. If the fertilizer needed, they can directly buy it from here. And if they are totally illiterate, they can listen the voice from directly here. And it's not static; it's dynamic. It changes based on the value, based on the dynamic value we are getting from the field. Then coming to the next important feature. We're calling it control panel. So we're calling it manual control. Okay. So these are like normal switches, the normal electrical switches we use to turn on and off electrical devices. So these are also works the same way. The user needs to manually click on and off the devices which are connected with it in the field or in the farm. So we are calling it manual because the user needs to manually toggle it to turn it on and off. So there is another thing is called automation. So user can put threshold. So let's say the threshold is 0 to 70, and when the soil moisture is in between 0 to 70, the device will stay turn on. When the soil moisture will be above 70, the device, let's say the water pump, will automatically turn off. So you can put the threshold here. So we have done some market research. We found that we're the only one who are allowing the user to put the threshold. Others are only giving hard coded values. So user doesn't have that power to change it. So then we have the schedule task here. So the schedule task is like we know how to schedule a meeting, or um, schedule a meeting, schedule a mail. It will send according to that time. But this is for the real life scenario. So you can schedule task. Let's say you want to turn on a light at 6 p.m. and it will turn off automatically at 6 a.m. Let's say you want to automatically turn on the irrigation pump every day at 11 a.m. and it will automatically turn off at every day at 11 a.m. And automatically it will turn off at 2:30 p.m. So even you can also, let's say the water pump, um, you want to select the days when you want it to be activated, specific days. Okay, you can also change the time as well when you want it to be activated. Let's say p.m. Okay, and then 4:46 p.m. to, let's say, 5:52 p.m. Okay, and this will be the active days. It will work according to that schedule. So if we go back to the overview, yeah. So we schedule the real life things, the daily things we use in our life. Let's say the light, the water pump. We can add as many devices we want, and it will work according to this thing. Then we have important feature, like let's say I'm talking right now. You can what should I say, that you can record video, you can capture picture, you can also time lapse, motion detection. So I think it's a very crucial thing. Let me take a picture. It not only streams the picture, the video. You can also check it directly here. So we have our own server which will be installed in the farm, and it is directly connected with with our system using tunneling. We're using Linux and Raspberry Pi for that purpose as well, and for the scheduling task. Those are self-hosted things, and we are communicating with tunneling thing. Um, yeah, so you can see the videos, the pictures. Even if you want, you can delete those. Okay. Then we have the crop predictor as well. So yeah, based on the collected data, we can also check that what is ideal for our soil. So based on the data, I'm just giving random values. Based on the analysis of your soil nutrients, optimal crop prediction recommendation is papaya. So we have trained a custom model, and based on that, we have verified it using Bangladesh Agriculture Research Institute. So let's move to the next section. This is our Agri AI chatbot. So you can ask it any question related to agriculture, and it will answer you based on your question in any language. So let's just ask it a question: what is precision agriculture? And then let's just wait for the answer. And here is the answer, you can see. So next section is related to farm management. We have the finance section here. We can see the overview, the expenses, the monthly expenses and income directly from here with the chart. We can also check the transaction. We can input the transaction directly here. We can see the income details. We can check the expense details, and as well as we can generate report. Let's say I want to see the income from January 1 till this day. 16th, and you can check the income and expense. Let's say I want to generate the PDF. So let's do it. Open it. So you can see that the income was from sorry, the expense was from fertilizer. Amount was 2,000. Category bank account description and everything with the seal of System Sage. If we want, we can also generate the income, and this time let's generate the CSV file. Um, okay, let's open it on the Microsoft Excel. So you can also directly export it to Microsoft Excel if you want from here. So that's it. And if you want, you can also check use the night mode as well. Um, it is equally applied to all the sections. And we have the profile section as well. You can check here if you want. You can edit as well. And we have another feature, we call it Pro feature, the next cloud. The QR code is not the Pro feature, it just easily allows other users to get the QR code from here and join the system or access the system. But for the next cloud, is like alternative to Google Cloud. We will host the server in your home and it will be connected to internet. We will configure the security and other things, the storage, the device. It will be running on Linux computer right now. It's running the different softwares. Um, so if you want, we can do that as well. That's in the Pro feature. So that's it. Now I will show you the hardware part. So this is our monitoring control module box. It will be set into the field. You can see the components here. This is powered by a solar panel, sustainable power source. All the components are inside the box. This is we are collecting the data from the ground using that sensor. After collecting that data, it is being sent to our cloud using that networking module. You can see the antenna there. This is our control module box. We are basically providing three types of control: the manual control, the schedule based control, and the automation control. For the manual control, you have seen some switches into our system. For automation based control, we can user can say, you can add some threshold, and for scheduling, user can use date and time and select the devices to turn on and off based on their requirement, some electrical appliances. So let's turn on and off some appliances to see how the things work. Uh, Basically, we will do the manual control, the automation based control, and you can see, and the schedule based control. So this way we can control the farm equipment directly from here. That's it. Thank you.